Hi everyone, this is Revathi M, Assistant Professor, Department of Computer Science, Artificial Intelligence and Data Science, Dr. S.N.S. Rajalakshmi College of Arts and Science. In this series, we are discussed about the machine learning. Today, we are going to discuss about inductive bias in concept learning. So, to generalize beyond the observed training data, inductive bias is a fundamental concept in machine learning as it is determine the ability of a learning algorithm to generalize beyond the observed training data. So this presentation explores the implication of inductive bias in the context of the candidate elimination algorithm, highlighting the trade-off between expressiveness of the hypothesis space and the algorithm ability to generalize. Next, we see the biased hypothesis space. First one is a restricted hypothesis space. The candidate eliminated algorithm was initially restricted to a hypothesis space of conjunction of attribute values. This limited the algorithm ability to represent more complex target concepts such as disjunctive hypothesis. The next one is the inability to represent target concepts. When the target concept was a simple disjunction of attribute values, the restricted hypothesis space was unable to represent it, leading to the algorithm finding no hypothesis consistent with the training data. Next one is a need for more expressive hypothesis space. To ensure the target concept is contained in the hypothesis space, a more expressive representation is required, such as allowing arbitrary disjunction, conjunction, and negation of attribute values. So unbiased learner, that is hypothesis space expansion. By expanding the hypothesis space to the power set of instance space, the learner can represent any possible target concept. This eliminates the problem of the target concept not being expressible in the hypothesis space. Next one is the inability to generalize. In unbiased learner, the inability to generalize this unbiased hypothesis space leads to a new problem. The learner is unable to generalize beyond the observed training examples as the version will simply be the disjunction of the positive examples and the negation of the negative examples. The third one is a unanimous voting futile. So attempting to use a voting mechanism among the version space hypothesis to classify new instance is also futile as each unobserved instance will be classified positive by half the hypothesis and negative by the other half. Next, we see the need for inductive bias. So, the fundamental property of inductive inference, a learner that makes no a priori assumption regarding the target concepts has no rational bias for classifying unseen instances. Inductive learning requires some form of inductive bias. Next one is a defining inductive bias. The inductive bias is a set of assumptions that allows the learner's inductive inferences to be justified deductively. It is an additional assumption needed to transform inductive inference into deductive ones. So, inductive bias of candidate elimination. The inductive bias of the candidate elimination algorithm is the assumption that the target concept is contained in the given hypothesis space H. Next, we see the inductive bias and generalization. So, first one is the target concept. The target concept that the learning algorithm is trying to learn. So, the second one is a hypothesis space. The set of possible hypotheses the algorithm can consider. Next, inductive bias. The set of assumptions that allow the algorithm inductive inference to be justified deductively. So, generalization. The algorithm ability to classify unseen instances beyond the observed training data. So we come to the end of this section. We conclude the inductive bias. The inductive bias is a fundamental concept in machine learning as it determines the ability of learning algorithm to generalize beyond the observed training data. So hypothesis space, the expressiveness of the hypothesis space and the inductive bias, it implies the crucial factor in the performance of a learning algorithm. Next one is a generalization. Bias-free learning is a few as a learner with no a priori assumption has no rational bias for classify unseen instances. So inductive learning occurs some form of inductive bias. So these are all the in this presentation, we discussed about what is inductive bias and unbiased inductive. So I hope you enjoy this section. Thank you.